Hi, everyone, and welcome to our next session in Quantum-Latino 2021. This session is called Women in Quantum. And I have the pleasure to introduce a fabulous woman who is going to chair this session, Denise Rafner. She's the VP of Business Development at IonQ. IonQ, you know, is a Tribe Ion quantum computing company based in Maryland. Denise is there responsible for all customer engagements and customer strategy. In her free time, she is the president of Women in Quantum, a rapidly growing organization dedicated to highlighting and creating a community for women. Previously, Denise was Chief Business Officer of Cambridge Quantum Computing. And prior to that, Denise worked at IBM for 18 years and was part of the early IBM Quantum team, responsible for starting the startup and ambassador programs and leading the worldwide sales strategy. Prior to IBM Quantum, Denise held a variety of roles in increasing responsibilities, including leading sales teams with annual cost of $750 million. And Denise has been recognized for innovation, sales leadership, and strategic planning. Fabulous to have you here, Denise. I'll let you now moderate and lead this fantastic panel. Thank you.
Thank you. Thank you, Araceli. Thank you, Martin and Raphael and team for including a panel on women in quantum in this event. And I have to confess, I don't speak Spanish and I need to learn it. And so I've told the panelists that if they want to speak in Spanish, they can and they should, and they can just look at me every once in a while. So we're going to try a hybrid panel. And I'm really excited to have all these fabulous women on the panel. So what I want to do is start off and have everybody introduce themselves. And we're going to start off with Laura Gatti, who I've met before. Laura, do you want to go ahead and introduce yourself?
Okay. I'm glad, first of all, I'm glad to be here with all this woman community that Denise makes grow day by day, thanks to you. I am a PhD candidate from the Polytechnic University of Madrid. I am finished the writing of my thesis right now. The main field is discrete sets of gates for quantum computing. And since last year, I am the leader research of Quantum South. That Quantum South is a startup in quantum computing that began operating last year. And I'm working with a group of 5 or 6 people. And by now, except by me, they are all men. But we are working that change in the near future.
I also want to mention that Quantum South was one of the finalists in the Airbus Challenge, which is really impressive. It's a very impressive accomplishment. So congratulations again. I think that's great validation of the talent of your group. Catalina, you want to introduce yourself? And you can speak Spanish if you want. So
it's fine. I'll do English.
Okay.
Hi, and thank you to Martin and Laura and Rafael for the invitation. Like me said, my name is Catalina. I'm also from Uruguay. I've been researching in quantum for 2.5 years now. I just got my bachelor in engineering, doing my thesis in hybrid neural networks. And yeah, I'm the only woman on my team as well.
Great, thank you. I have Marta. Let's meet Marta.
Hello, good night from Spain. Thank you very much for creating these spaces and encouraging women to talk about our experiences in quantum. I'm Marta Estarellas. I've been working in quantum technologies for the last 6 years. I'm now based in Barcelona. I work for a startup company called Qilimanjaro. This is a full stack company that is it was recently created as a spin-off of academic institutions. And yeah, I'm very happy to be here.
Thank you. We're glad to have you. Romina.
Hello, everyone. I'm Romina. I'm a quantum researcher in applied research in JP Morgan Chase in Buenos Aires. Prior to this, I worked as a software developer in JP Morgan for 2 years. Also, I got my licenciatura degree in physics from the University of Buenos Aires in 2018 after completing a thesis project in bioinformatics at the Leluar Institute, also here in Buenos Aires. And prior to that, I did an internship in the tire company called FATE in Buenos Aires, and I was a summer student at CERN in Switzerland in 2017. And thanks a lot for inviting me. This is super exciting for me.
And I want to do a shout out to the JP Morgan Chase team. I know there's a bunch of people watching this panel, and I want to thank you all for your support and tell you how fun it is to work with you. So let's move on. And I don't think Samurai is joining. So last but not least is Catalina.
Hi. I'm going to do this in Spanish because I know many people feel more comfortable in Spanish. Yo soy embajadora de computación cuántica de IBM. Estoy basada en Colombia. Es un placer para mí, Denise. It's a pleasure for me to be here with you. Creo que estos espacios son muy importantes para que todas las personas, hombres y mujeres, se visibilicen de lo que logran las mujeres en la computación cuántica, y me alegra mucho ser parte de ello. Para lo que necesiten de IBM en computación cuántica en América Latina, no duden en levantar la mano. Yo tengo background de ingeniera, pero pues el campo de la computación cuántica es apasionante. Entonces, aquí estoy.
So Catalina is an IBM Quantum Ambassador, which is a really great achievement. And so I'm so happy you're on the panel. So thank you for joining us. I do also want to mention that Samurai Brito is supposed to be on the panel, and she may join us a little bit late. So I wanted to just welcome her and let the audience know that she may come, and we'd love to see her. So what I wanted to do today was just talk a little bit about women and diversity and quantum computing. I think the achievements of all the ladies in the panel are very impressive. And I wanted to find out, maybe to start off with, is how you got into quantum computing. So Carolina, could you tell us how you got into quantum computing?
Okay, sure. It's been a wild ride. It all started when I was 16. I really liked quantum my whole life, and I knew that I wanted to study that, even when I didn't understand the math or anything behind it. So when I finished school, I started a bachelor's degree in physics, which I left about like halfway through. Then I got into engineering and electronics. And when I was doing my senior year, my two now tutors, Andre Fonseca and Efraim Buchmann, who I think is in the audience, told me there was like this degree in the quantum computing group. They were looking for a junior researcher who wanted to like explore into quantum computing. I had no idea what it actually meant, like beyond the math and the physics. I didn't know there was that the whole branch of quantum computing even existed. But I've been in there ever since, and I love it.
That's great. That's great. Marta, how about you?
So my route was a bit different. I was doing chemistry, and after my degree in chemistry, I moved to a master's that was focused on computational modeling and theoretical chemistry. And my master's thesis was to do drug design using computational models. So we were using supercomputers, and all my calculations were taking forever. They were taking months, and it was very frustrating. And at the same time, while I was programming these simulations, I got very much into computer science, and I decided to start a computer engineering degree. And at the same time, with the frustration and learnings in parallel about computer engineering, I found somebody told me that quantum computers could solve all this time I had to wait for my calculations to be done. And I decided to apply for a PhD on quantum computing afterwards.
That's great. Great story. A lot of us, I'm a biologist, have spent many weeks waiting for computer results, and it certainly is frustrating. Romina, tell us about how you got into quantum.
Well, when I was studying at university in the University of Buenos Aires, I always loved quantum mechanics. So it was an area of research that I really liked to pursue in the future. But how I ended up working in quantum computing is very interesting. I volunteer in an NGO that is called Chicas en Tecnología. Is from Argentina, but is present in Latin America. So it was almost 4 years ago that I was volunteering in an activity carried by them, and JP Morgan is one of the sponsors. So I was mentored in a hackathon during a weekend for teenagers in one of the offices, and it was there that I found that in JP Morgan they were looking for scientists to join as software developers. So after that, I was interviewed, and then I joined the company. So I worked doing software development for 2 years. And then I realized that I could put together these two things, the software development that I learned from my professional experience with what I liked at university. So I think that quantum computing was the perfect match for that. So I moved to this team that is called the Future Lab for Applied Research, and I started working in quantum algorithms.
And I think you work for a fabulous team, and you know that. So it's really exciting.
Yeah.
So, okay, Laura, how did you get into quantum computing?
Okay, I think that I share the history with Catalina because the tutors, were my tutors when I began to study quantum computing. They promised to me that in quantum computing I would find a lot of math that I loved. And then I started to research with them, and I don't know, it's the same story as Catalina. So
Great. Actually, Catalina has a little different story. So maybe Catalina, you want to tell us about your journey?
Yes. This one I'm going to tell it in English because it involves you, Denise.
Oh,
so
okay.
Part of my journey to quantum was thanks to Denise. My boss at IBM, when I joined IBM, I had no idea that quantum computing existed. So when I joined IBM, a month or two later, my boss gave a talk, to people who had just joined, about quantum computing, very introductory, but it sounded interesting. So I started doing a little bit more research, and I asked, I want to take a course on this. I know that IBM is good at it. They have courses. And someone at IBM Colombia said, oh, no, you can't, because you're not a physicist and you're not a mathematician. It's not you didn't study that. So this is only for physicists. And I was like, what? That's wrong. Give me an exam. I can do an exam and prove you wrong. But that was not the right way. So I started studying on my own, probably like many of the people in the audience. You start by looking at the videos, Coding with Qiskit, and you go and read the textbook and go to all of the talks. And one of these talks was Women in Quantum. And at these Women in Quantum summits, at one of these smart speed dating things, I met Denise. And by then I already had a couple of months of experience in quantum. And she told me oh no, you should become an ambassador. I mean, this is something that exists and it's not limited to physicists. So there was a preconception that this random person in Colombia had. And I want this to be a motivation for everyone. There will always be someone on the road telling you that it's not for you, but you have to make the road for yourself. If it's not made, you have to pay the path and try to find the right people. Go to the Women in Quantum, whether you're a man or a woman, and you may have the same chance, maybe, as I did.
So the IBM Quantum Ambassador Program is a wonderful program. I was involved in it. It's now led by Robert Laredo, who's fabulous. And so I'm so glad you're part of it. It's a really great experience, I think. So one of the things I wanted to talk about is kind of at the beginning, Laura said, oh, I'm the only woman and there's 5 men. And I think all of us have the experience that there aren't that many women in this industry. And it's the reason why I started the Women in Quantum organization was just to highlight some of the accomplishments of women like the women on the panel, because I think there are women out there that are very accomplished and they need a chance to tell their story. And one of the things I do want to talk about is quantum computing in South America. I'm really proud of Quantum South and that they were an Airbus finalist. And I think they are the first quantum computing startup in South America. And I just wanted to ask each of you your perspective on the development of more expertise in South America on quantum computing. That's my mother calling, sorry. I have to turn off my phone. Laura, why don't you start talking since you're from Quantum South, and then we'll progress and talk about what's happening even in your country in quantum.
Bueno, siguiendo a Catalina, me voy a sumar también al español. Sorry, Denise, but it's easy for me.
Spanish.
Creo que en Latinoamérica estamos recién conectando con la importancia de abordar este tema en los primeros tiempos. Estamos todavía en un avión que está despegando y todavía estamos a tiempo de tomar este avión, y en cuanto formemos un capital humano que nos permita tener una variedad de recursos humanos para desarrollar el tema, creo que todavía estamos, aunque vamos atrás, estamos con capacidad de seguir este tema de computación cuántica desde una primera línea, y creo que el desarrollo de lo que pasó con Airbus y con Quantum South, la spin-off que formamos, es un claro ejemplo de que cuando un grupo de personas se pone una meta, lo puede alcanzar y puede lograr excelentes resultados, y que eso no depende tanto de los recursos que tengamos, sino de la voluntad que tengamos para realizarlos.
Thank you.
Sorry, Denise.
That was great. That's fine. Carolina.
Well, I'm going to join everyone speaking Spanish, so
Sure.
sorry, Denise. Bueno, yo estoy plenamente de acuerdo con lo que decía Laura recién. Estamos recontra en pañales, recién empezando. Acá en Uruguay, creo que me atrevo a decir que con Laura y 2 mujeres más, somos la totalidad de las mujeres en computación cuántica. Y salvo por Quantum South, y esto, por favor, Laura, si sabes de alguien más, corregime, creo que no hay otra empresa en Uruguay que esté metida en computación cuántica. Todo el resto de la investigación que hay es a nivel académico. Y sí, muy de acuerdo con eso de que hay que subirse al tren antes de que pase. So.
Okay, Romina.
Well, for me, I'm really impressed on the talent that we have in the region. As I said before, I studied at the University of Buenos Aires, so I can assure you that we have very good talent, amazing scientists that I'm totally sure that can contribute to the development of quantum computing and also communications like quantum technology in general in the region. So I see a really prospect future for the field here. And I think that these kind of events, such as Quantum-Latino, is something that we really need in order to raise awareness across the different communities in Latin America about the importance and all the value that these technologies can bring about.
Totally
agree. Great. Marta.
Well, I'm from Spain, and unfortunately, I cannot say much about South America and the situation, but I can maybe highlight what's my experience with Spain, which I think I have the feeling with what others said now, that it was very similar a few years ago. So when I left for my PhD, that was 6 years ago, there was barely open positions in Spain in quantum. And that's actually the reason why I had to leave. And after my PhD, I even had to go to Japan because there were still not many positions going on in Spain. But now that I came back, I'm seeing that quantum technology is expanding very quickly, not only in Europe and in the United States and China and around, but also in Spain. And I think this is something that is going to be generalized in many countries. And hopefully in South America as well.
Catalina.
Yo me uno a la analogía que dijo Laura, y es la del avión. Creo que el combustible de ese avión son las personas. Entonces, los esfuerzos que hagamos por que más personas se involucren y se interesen por esta área, siempre van a ser combustible para ese avión de la computación cuántica en la región. Y adicionalmente, el hecho de tener más startups y, digamos, educación transversal, no solamente en la física, sino en los diferentes componentes de la computación cuántica, desde, pues sí, desde la física, pasando por la ingeniería, pero también hasta el nivel de empresarial, van a ser valiosas para seguir construyendo este ecosistema y que ya no sea un avión, digamos que solito, sino que vayan a ser muchos aviones, muchas empresas, no solo, digamos que dedicándose exclusivamente a la computación cuántica, sino aprovechando la computación cuántica para sus diferentes industrias. O sea, independiente del área donde esté esa empresa, queremos ver, y yo creo que va a pasar más pronto que tarde, que esas diferentes empresas aprovechen la computación cuántica y ayuden a crecer el ecosistema.
Great, thank you, and hello, Marco. Sorry, I got a text. What I wanted to talk about is I think all of us, are always trying to learn more about quantum computing, and a conference like this is a great place to learn more. But I always have like my secret resources for learning quantum computing, and it's kind of one of my hobbies is to find new books or new websites. And one of my favorite websites is kind of new for me. It's called quantumcomputing.com. So I don't know if any of you have checked out that website, so I'll recommend that. But I'd like to hear from each of you in either English or Spanish on what your favorite resources are so you can help the audience broaden their learning in quantum. So Laura, you want to start?
Vale. Este año en la Universidad de Montevideo, que es donde estoy trabajando ahora, empezamos a dar un curso en computación cuántica, en el que nos enfocamos más bien no tanto en el área física, sino a crear ingenieros de computación cuántica. Entonces, en esta búsqueda de material, hemos encontrado que las propias empresas que generan computadores cuánticas también generan mucho material que es increíblemente bueno para la divulgación de su propio prototipo. Entonces, yo creo que para la gente que está aprendiendo a manejar la computación cuántica, los simuladores que ofrecen, por ejemplo, IBM, es espectacular la cantidad de información que tiene. Pero también está otros tipos de computadores que también lo tienen. Es una excelente forma de empezar a conocer el área, empezar a programar, empezar a probar, empezar a ver que se pueden hacer códigos sin tener conocimientos ultra detallados de lo que es el área técnica profundo, si se quiere.
Thank you. Carolina.
Yeah, I'm going to join in and also say that I love IBMQ. It really helped me through my first baby steps into quantum. I'm going to recommend a book, which was like the Bible behind which I wrote my thesis. That is Quantum Information and Computation by Michael Nielsen and is it Chuang? It's my absolute favorite book. It's really well written, really clear. Because at least when I first started, it was really complicated to put everything apart and start to like understand little pieces of everything. So yeah, that book, my favorite by far. And also, I'm a really big fan and advocate of science communication. So I'm gonna recommend a non-technical thing, but Minute Physics on YouTube has a series of videos, I think it's 4 or 5, explaining the famous quantum algorithms, just what they do. and what they're capable of doing. And they're actually very, very good if you're just trying to understand the main idea and not the math behind it, at least to begin with.
I've never heard of that. That's great. Thank you. Romina, what about you?
I think it's really important to have a network that supports you. It has happened to me since I was in high school, that I started asking for advice to my teachers and also to my professors at university. And that was crucial for me to understand what I want to do and what resources I have out there. And for my professional career, how I moved from software development to quantum research, it was also super important to be in touch with different people that give me their point of view so as to pursue this career and to be able to succeed at it. So I think I will encourage everyone that wants to join this field to be in touch with the community and to participate in every event that they can, because it's going to help you to move forward and to be able to ask for advice, to chat with someone that you admire and you like how this person thinks. It's great to ask for help and to advise.
Great, and I agree. I see Xiaohan on the chat. He's someone I always went to for advice. So there's a lot of great people out there that are always really helpful. Marta, what resources have helped you learn quantum?
Well, I think I share very much the resources that were already recommended, but one that it might be a bit technical, but I think it's a good and free way to get all the papers and the state of the art, what's actually happening at the last minute, and it's the archive. The archive is a website that publishes all the papers that are coming out. So you know that in academia we publish papers and usually we submit those papers into journals, but Archive is a platform from Cornell University where you can, in parallel that you submit to the journal, you can also submit there. And you can access those papers for free without having a license to access the journal. And it's totally legal and it's totally accepted by the journals. And it's a good way to have access to all these physics papers that keep coming out very fast every day.
Yeah, I'm messaging someone to find a website. So let's see if I get that back. We've talked a little bit about IBM Qiskit and all the education at IBM. So Catalina, maybe you can talk about what's been most useful for you. This is a perfect lead-in for you.
Yes, totally. Right now I'm sharing the link to the Learn page of Qiskit. And here you'll find videos, blogs, textbook, tutorials. It depends on everyone. So for me, I love the videos. I started with the videos and I think it's like the best way for me to learn, but each person is different. Also, the course, Introduction to Quantum Computing and Quantum Hardware, it has 27 lectures, it has labs. And this is something that I want to reinforce. Do the labs, do the challenges. I'm also gonna share a link to the Qiskit community GitHub. And here you will find all of the past IBM Quantum challenges. And this is the way that I think I learned the most. Do, not only read, not only see, but actually go into Qiskit and try to program whatever algorithm or whatever you're seeing.
That's really good advice. Are you putting the links in the chat? Yes, okay. I'm going to put one more link in the chat, and I don't know if you guys all know about this, it's called scirate.com, and it's a website that was actually started by Dave Bacon, who's now at IonQ, that shows you the top-rated physics papers of the week. So that's my secret when I can remember the name, is I typically go to Scirate and go, oh, what's new? What's fabulous? And so it's another way to see what's going on in the literature. Now, one of the things I do want to mention is that there is an academics credit program at IonQ, and I'll put a link in the window, that if you want free access to a trapped ion computer for an academic project, we actually have free credits right now. So I think that's a great way to learn, is as Catalina said, to challenge yourself to do problems. So want to mention that to you. I think next where I want to go is, we've talked about resources. We're also, one of the issues that I've seen as kind of the transition from being at the university or getting your degree or doing a postdoc and thinking you're going to be a professor and all of a sudden ending up in academia, or I'm sorry, all of a sudden ending up in industry. And I'm wondering if you guys have any advice about that or any thoughts about that. I typically meet people and they're nervous about it. And so I'd love to hear what your thoughts are, like Laura, about working at a startup, and what that experience has been like for you. So maybe Laura, we start with you.
Ok. Yo creo que la diferencia principal entre la academia y la industria son los tiempos. Creo que en la academia nos tomamos más tiempo para tener resultados que sean académicamente interesantes. En cambio, en la industria lo que tenemos es que resolver problemas. Entonces, ahí hay una diferencia sustancial, porque en la academia estamos abocados a las investigaciones que en sí tienen una finalidad o no es nuestro objetivo principal. Ahora, cuando nos pasamos a la industria, tenemos que desarrollar y crear elementos útiles para esa industria. Tenemos que crear valor de alguna manera, de un valor mucho más tangible del que podemos crear en una universidad. Entonces, los tiempos son sumamente más difíciles de manejar para hacer investigación, y creo que eso es una de las grandes frustraciones que lleva a pasar de la academia a la industria, y creo que es algo para lo que los científicos no nos forman. No nos forman para pasar a la industria, sino que directamente nos forman para quedarnos dentro de la academia, y creo que ese es un salto que nosotros tenemos que dar también como profesores, en instar a que nuestros alumnos se animen a salir a la industria, porque es donde verdaderamente se termina de concretar el valor de nuestra producción académica. Y algo que refiere a la pregunta anterior, me parece que en Latinoamérica lo que pasa es que la mayoría de la investigación se hace dentro de las universidades. Hay grandes estudios que muestran que altos porcentajes de la producción académica se hace dentro de la universidad, y creo que en Latinoamérica tenemos que abogar porque cada vez esa producción académica se haga fuera de la universidad y más en las industrias, que es donde más va a generar trabajo y capacidad para abarcarnos justamente como trabajadores también.
Marta, what can you tell us about the transition from academic to working at a startup?
I can tell that I was very nervous about that. I was actually pursuing the academic path, and all of a sudden I decided to move to industry because I thought the project was interesting. So I couldn't agree more with what Laura said. But the main difference are the tempos, are the times, because in academia you work for the sake of science, for the beauty of it, for expanding the horizons of physics and quantum technology, but without necessarily trying to find a commercial application, right? But in companies, in industry, at the end of the day, you want to sell something, and this something needs to be useful for society. And the path that you follow is a little bit narrower that you will follow in academia, maybe because you really need to focus on creating this application. I think this is the main difference.
Romina, do you agree with that?
Yeah, I do. I totally agree, and I think that's the thing that I most like about working in a company is that we try to address real business problems. And this is something that I've searching my whole life since I was studying physics. I wanted to apply all my knowledge in order to solve a real problem. And it's incredible how in a company we are able to detect business use cases, propose a solution using quantum computing, and also being able to test that solution and to bring value to our business. For me, being part of that end-to-end process is amazing. So yeah, I really enjoy working in a company.
Great, thank you. Yeah, working at a company is a little bit different, but actually I think it's fun, and it's, you know, I've even seen people go back and forth between academia and companies. So there's a lot of latitude, I think, for everybody. What I want to ask each of you is what the most challenging part of your job is. I know for me, it's keeping up with the science and trying to find a way for me to talk about the science in a way that a lot of people understand it. But I don't work as a scientist. So Laura, what challenges do you have?
Ok, creo que quizás lo más complicado es estar en la cresta del conocimiento. Creo que hacer una investigación a veces llega a 6 meses y cuando uno está haciendo una investigación está terminando un resultado, aparece otro campo nuevo que está asociado y seguir el ritmo en este momento en computación cuántica es extenuante. Es todo el tiempo hay que estar mirando archive como creo que una de las compañeras decía. Y nada, es como Marta decía, y eso es, creo que es en este momento, el nivel de producción que hay es brutal.
Thank you. Carolina, what challenges you, or what are your biggest challenges in your day-to-day quantum job?
Well, I agree with Laura on this one as well. Keeping up with the pace at which knowledge is being produced is overwhelming. Even when you try to find, like she said, if like you're doing research that lasts 6 months, and when you begin doing research, you do a background check, and no one is doing exactly what you're doing. You're good to start, then you go, and when you get to the point where you're about to publish something, you find out that someone halfway around the world beat you to it, like for a month. And it's really frustrating. Even though I love my job and I love everything I do, it's really frustrating when you find someone who published like the same thing you did maybe a month before you did it. So yeah, I agree that the most challenging part is keeping up with the pace at which papers are being produced.
Yeah, agreed. Romina, what about you?
For me, the biggest challenge is to find the use cases in which quantum computing can bring value. We know in the last couple of years there has been a huge development on different quantum solutions. So it's challenging to be able to recognize which problems are the ones that we can address with quantum so as to bring the most benefit out of it. And then also to develop that solution and to being able to iterate over that solution so as to best address these problems. But also is the most exciting part, to be in constant challenge. And as the colleague said about these to being up to date. So there are many developments being done. So be up to date with them. It's also a huge challenge.
Marta, what about you? I think you're, are you doing hardware development at Qilimanjaro?
I work in theory. I'm a theorist.
You're working theory, okay. So tell us your challenges.
So I think there are 3 main challenges for me in my daily life. It's first of all is that at the end of the day, quantum computing, quantum technologies are still in its infancy. So any direction, any decision you take towards this roadmap is a challenge, and all the developments are a challenge because quantum is challenging. And the second is what the others have already said, is to keep up with production, because it is fortunately it is a very fast developing field, and we get. I was mentioning before that I subscribe to this mailing list where I get the papers every day, and the first thing I do in the morning is to check all these papers with the abstracts, which is a little summary of what's been done, and it's amazing how many I get per day. It's getting very fast, and it's very difficult to keep up with that. And the third one is to focus, because when you really like your field, when you really like your research, it's very difficult to not be chasing new shinies, new projects all the time, and to start a project, finish, and then start the next one, and not having like too many projects that you cannot finish. So that's a personal challenge for me.
I think focus is a challenge in any role. Is how do you finish something out before moving on and really stay focused, because there's something else different and interesting. Catalina, tell us what your greatest challenges are.
Para mí el reto es lograr que las empresas entiendan que es una tecnología que está en desarrollo, pero que vale la pena entrar desde ya. Las empresas, por lo menos en Colombia y en muchas partes de Latinoamérica, están acostumbradas a que los productos ya están terminados. Llega una empresa y dice, te vendo el nuevo computador y ya. Y lo compran y se acabó. No tienen que esforzarse por aprender y entender la tecnología y por adoptarla incluso desde sus inicios. Entonces, eso es un reto, lograr ayudar a que las empresas entiendan que esto es algo que se crea en conjunto, que las aplicaciones las conocen más ellos, pero que se tienen que desarrollar. Digamos que no está ya todo hecho. Eso es difícil, pero pues también es la parte interesante del trabajo.
Great, thank you. One of the things that we have a Women in Quantum panel for is to talk about diversity and kind of reach out to the audience and give the audience our opinion on how they can help bring more diversity, whether it's women or whatever we define diversity as, into quantum computing. And I certainly think, like a lot of events like this where people can attend for free, are really great to encourage different people into this ecosystem. And I just want to ask each of you, if you could ask someone in the audience how they could help or what they could do, what would that be? So I'm going to start with Catalina. Catalina, what would you ask?
Well, I would tell them to motivate their daughters, nieces, sisters, any sort of younger relationship that they have with any women, to encourage them to not pursue science because they don't necessarily need to like it, but at least show them that it's a viable option. At least in Uruguay, women tend to be more encouraged towards like teaching, or more like social sciences. Like the hard sciences are not meant for women here, and you'll get mocked a lot. I used to go through that in school. Don't do that. Don't do that. Show the women in your environment that science or engineering or STEM, better STEM, is a viable option. And they don't need to like it. Maybe they don't, but at least you get them to consider it as an option, as a career option. And if they said, no, this is not what I want to do, at least it'll be because they don't like it, not because they think they can't do it. So motivate the women in your environments would be my tip.
Marta, what about you?
I think it's a very basic. I really agree with what Catalina said, but also I would like to add that it's very important to do a personal exercise to self-educate yourself, to try to gain conscious on your surroundings, in your company, in a meeting, and try to listen to your colleagues, to your female colleagues, that many times, especially in our field that is not very women populated, are feeling maybe shy, maybe they have a huge imposter syndrome, and maybe they feel they have to shout to get heard. Maybe just listen to them, see what they have to say. And I think people will be very surprised how this has a benefit in how women get more confident and more comfortable in those meetings, and also for other women working in the field. I think we have some sort of responsibility to also help in that education in our environment, to not only to encourage women to come and also and create safe spaces and comfortable spaces where they feel they are being heard, but also making our male colleagues realize that we are no different at all.
I also do think that women think differently, which is neither bad nor good. Like, we all approach problems in our own way. And I always love diversity of thought when you're in a meeting. I think that's really great. Now, Romina, I know you do a lot of outreach. And so maybe you want to talk about some of the work that you do, which I think is just wonderful in encouraging chicas in STEM, I think. So why don't you talk about that a little, tell the audience about that a little.
Yeah, I think it's really important to encourage teenagers to not to get involved in STEM, but to be aware of the existence of all the possible careers of studies and all the possible positions that they can have in this space. So this organization, this NGO that is called Chicas en Tecnología, they carry different activities, most focused for teenagers. So I think it's great to volunteer in these activities in order to show them what is science, what they can do in science, and also to have this network to see other teenagers that are in the same situation. They are trying to see what they want to do in the future when they grow up, and also to have role models, maybe some other woman that has gone through that experience. So also I feel this responsibility of being involved and also to help other people, as so many people has helped me to go through my career.
That's really great. Laura, do you want to add to that?
Oh, I think that I agree with all the panelists, and they explain it perfectly.
Okay. I think for everybody in the audience, being a role model, being kind, encouraging women to think outside of maybe traditional roles, it is really important. And so I think it's something that all of us, there's a lot of people on, and I thank you for listening, to really be encouraging to everybody to continue their education, to think differently, and have different, encourage non-traditional roles for people. I think we all need to expand our education. One of my next questions is kind of a fun one. What area of quantum computing do you think is going to have the most growth in the next year? And I know this is very speculative, but maybe you could even talk about what you're doing and where you think that's going in the next year. And let's start it with Catalina.
I couldn't unmute myself. Well, I am just going to throw my prediction out there, but I want to say before I say it that for me, quantum has a lot of someone one day shows up with a new algorithm that does something and is really good at it, and then everyone goes in that direction. So I don't think I would be able to actually predict anything, especially because of that. I think the neural networks and artificial intelligence branch is growing rapidly lately, trying to come up with hybrid models. That's part of what I do as well. So I really want that to go forward. But I think cryptocurrencies and crypto as a whole will be like the next big thing, at least in like the immediate future. Especially because crypto in and of itself, like besides quantum, is a really big thing right now. So I think maybe those two things will go together and see surge.
Cool. Marta.
Yeah, that's a very difficult question, Denise. So the answer is that I don't know. So I think we will see different phases. We'll see non-universal quantum computers. Once we can implement error correction, we'll have universal quantum computers. I expect quantum annealers to come first, to be able to tackle certain optimization problems, and then we will see gate-based large-scale quantum computers to tackle more universal problems. But I think what will come first is knowledge. I think we don't have a market ready yet for a quantum computer. And the first thing that we need to do is to educate and help industries to understand how quantum computing can help, and help them identify those algorithms that could help be useful for their daily lives. Is something that Romina said, I think, before, to identify use cases. This is something that will come first, because we cannot do anything without that.
Well, that's a good, Romina, why don't we go to you? That's a great segue.
Yeah, I totally agree with Marta. Yeah, I think that the development of quantum computing will be driven by the use cases. So I think that optimization is going to be one of the things that are going to grow the most, because in different industries, such as in finance, in chemistry, also in the pharmaceutical industry, it's full of optimization problems. And we know that quantum computers can solve these problems with a huge advantage over classical computers. So I think that in that sense, that's one of the areas that are going to grow the most in the next couple of years.
Laura, what do you think is going to grow the most?
Okay, I think that right now in Quantum South, we are developing optimization problems for air cargo. So I think that there is a lot of space to grow in optimization problems that quantum right now can offer some speed up. I don't know. I can guess the near future, but I think that optimization is an area that can be very productive to work with quantum computing.
That's great. It's interesting that all of you have focused a little bit on optimization. And one of the things that we're looking at IonQ is machine learning. And then I think a lot of people still focus on chemistry. So I think there's still a lot to be determined in this area, and a lot of it has to do with the devices and getting error under control. So it's still to be determined. I think one of the fun things that I do is I have a circle of friends, and every year we ask ourselves the same question and kind of put it in an envelope, and then a year later open it up. And it's fun to see how the industry changes from year to year, and what if our predictions were right or wrong. So I encourage you all to think about that and think about what your predictions are. All right, one more question, and we're running out of time. I think what I'd like to talk about just a little bit is in is, I'm stuttering here. What is a final thought that you would like to share with the audience on quantum computing? And we'll just start with Carolina.
I'm going to say what I always say when I try to talk about quantum. Quantum is not what Marvel is marketing it to be. And it's nowhere near what Marvel says. It's not like everything that you can't explain, then you go to quantum. Because I get that a lot among my friends when I say that I work on quantum. They're like, oh yeah, the Ant-Man and WandaVision thing. No, it's got nothing to do with that. It's not magic, it's science. And I think it's the next big thing.
Okay, Marta, what final comment do you have?
I can share what makes me like quantum computing that much, and it's the fact that it's we don't have answers yet. So, for instance, we don't have answers to the previous question, Denise, and the fact that we are working and we are helping develop technology with such potential that we don't know the potential, we don't know what the reach will be. I think it's very exciting. So I really want to encourage everyone that it's at least a little bit interested to try to pursue this career, because I think it's going to be very exciting in a few years.
Okay, Romina?
I would like to say that this field is exciting. It's growing a lot, and we are all learning through this journey. So I think that everyone can contribute to the development and the progress of this field from different perspectives, all types of scientists, physicists, computer scientists, mathematicians, chemistry, engineering. So I think it's great that we are all together trying to make progress on this field. So I think it's great to see that there is a enormous prospect for the years to come regarding this technology and all the things that we can solve with this amazing technology.
And Laura?
Como creo que es un evento de Quantum-Latino, creo que para mí lo más importante destacar es la urgencia de que en Latinoamérica desarrollemos más esta área en tiempos tempranos, y creo que también es la urgencia de crear programas de maestría y de doctorado para que se cree un mayor capital humano que nos permita crecer y empezar a generar industria en esta área desde tiempo temprano desde Latinoamérica. Creo que eso debería ser sin duda lo fundamental que tenemos que trabajar todas en este caso para fomentar aquí que la gente pueda estudiar y que crean que es algo que se puede hacer desde el sur.
Okay. One other point that I want to just talk about, and we're getting a lot of thumbs up and claps for Laura's comments, is the area of hype and accurately describing quantum computing when you talk about it. So wanted to see what your thoughts were there, Carolina, because I think that's something really important for all of us to be responsible and talk about this technology responsibly. I don't know what you would add to that, Carolina.
I try my best to science communication, especially in quantum, because at least, I mean, I think it's the same for Latin America, but in Uruguay, at least, people have no idea quantum computing exists, or that it's done here, or what it is that we do. So I try to reach out to science communicators here. I've been invited to a couple of podcasts in Spanish, which I'll link here when we finish, because I have to look them up. And I try my best to use analogies a lot. I mean, there's obviously the need to remove the math, obviously, but I try to do that in a way that still uses examples taken from physics or something related to science, because I find that a lot of the time people think quantum computing is magic, especially when they're not linked to the industry or engineering or physics or math. I think Marvel has done that for us. Quantum computing equals magic, and that's not it. It's science, it can be studied, it's really cool, and we do it here in South America. And it's not just something that you throw in when you can't explain a plot line.
Yeah, Catalina, I had seen that you had left earlier. So, Catalina, you want to comment on that? I apologize if you've been here.
Oh, yes, yes. I only had a temporary internet issue, but I was here all the time.
So sorry.
Yeah. Well, let me answer the previous questions then. About the being a woman in quantum, I think it's important also to promote people not only when they're young, but also as they advance in their careers. It's not too late to join a STEM field. I think that this is something that is often forgotten. Of course, many people get into STEM fields when they're because they have good, positive female influences when they're young. But many people discover STEM when they're older, and it's okay to change fields to a STEM field later in your life. So don't be afraid to change. I mean, of course, it's scary. It's scary, but don't be afraid to change a path. And regarding what is the next big thing, right? I agree with the part that algorithms is a very important part, not only in artificial intelligence and not only in optimization and not only in simulating chemical systems, so in quantum systems. It's a combination of all of the three, which is gonna make a difference. And I think I forgot one of the questions. I'm sorry. There were a few. But I do agree that it's important to join, like there's a lot of hype, yes, but get excited about it. Don't oversell it. Just get the information and go to the events and get into quantum and help build the quantum community. Also in Spanish. I'm speaking in English, so not very good example, but try to expand the knowledge in Spanish too for people who don't know English. I think that's also very important.
Romina, do you want to add to that?
Yeah, I agree that we don't have much books that are translated from English to Spanish. So in my case, it was like, I think in the middle of the careers of study that all the books were written in English. So I think that that's a limitation. And it would be great to start producing some content in Spanish, and also to show us, as we mentioned in this panel, all the talent that we have in the region, so as to be part of this disruptive technology.
Laura, I think you would want to add to that about getting more materials in Spanish. I don't know what your opinion is here.
Hablando en español es difícil, pero creo que en definitiva tenemos que leer todos la literatura en inglés en cierta manera, es una parte de nuestra carrera que tenemos que hacer. Y lo que pasa a veces con las traducciones, creo que se traduce poco y nos terminamos enfocando en las 5 traducciones que hay y dejamos de leer el resto de la literatura. Entonces, yo no sé si difiero con mis compañeras y hablando justo yo en español parece paradójico. Creo que no, creo que debemos acostumbrar a nuestros estudiantes a que lean en el idioma en que se produce la literatura, porque si no, luego siempre se genera un desfasaje que es imposible de llevarle la línea.
1 minute, Denise.
Okay. Araceli, I don't know if you're on, but Marta, why didn't you make a closing comment?
About the language?
Yeah, sure.
Yes, I agree with what Laura said. We like it or not, the literature is in English, science is communicated in English, and I think if we want to pursue scientific career, we don't have other choice than learning English. I agree it would be nice to have materials in Spanish, maybe for universities, for undergrads and so on, but if we want to go further into the scientific path, we need to learn English, and that's what we actually all had to do.
But I will say that I think being able to communicate in Spanish and have materials in Spanish is also very important to encourage people. Romina, I don't know if you want to add to that.
Yeah, I think so. Yeah, mostly when you're a teenager and maybe you are at the secondary school, at high school, that you may need to see that there are some material written in your language.
Yes,
because also it shows like that there is material that we are producing in the region. Because if not, you may have the wrong idea that there is no knowledge being generated here.
Okay, anybody else want to speak up on this here? No? Okay. I'm wondering where Araceli is. I know we're going over in time.
Yeah, I'm just waiting for you to close. Yeah.
Okay. So I've been waiting for you. So I don't know if you want to make any closing comments as another woman in quantum.
No, I was listening to all of you. I think it was a fantastic panel, a fantastic discussion. I agree with all what you said. Really, I think we can do it, and we just need to show it, that we have the same opportunities, that whoever wants to do it, that they can. And this about role models. I have mixed feelings. I never had any role model, and I am where I am, but it's true that a lot of people need role models. So let's just try to show these role models to the people who need it, and hopefully in the future there will be this 50-50 that we are looking for.
Great. Thank you, everyone. Thank you, Araceli, and thank you for this opportunity to highlight women in this industry. And I'll hand it over to you, Araceli, and thank everybody on the panel for all their contributions and wisdom.
Thank you, Denise. Thank you for the fantastic panel. Thank you, everyone. We have one more session and then the closing. I cannot believe that Quantum-Latino 2021 is almost finished, but head over to the session now with Microsoft. Thanks again, ladies, and see you soon. Bye.
Thank you, everyone.
Thank you. Bye.
Thank you. Goodbye.